Welcome to 9.3, Perform Reflections. Let's figure out how to reflect objects over a line of reflection. So if somebody asks you to reflect something, a figure, then you need to ask them, what do you want me to reflect it over? And it's going to be a particular line of reflection, and we can think of it as a mirror. So our essential question is, how do I reflect a figure in any given line? In our case, it won't be, there's only a particular number of lines, that types of lines that they'll give to us, but there are a number that we need to kind of figure out how to do that. So let's go to the textbook, take a look at this, and so this is kind of a useful little image here. So here is your line of reflection. And as you guys know from our 9.1, here's the pre-image, right? This is what we're starting with. And then this is the image. So you might think of, let's do Z. That would make sense, right? Z, if we start with point Z, the top of this guy's ear, and we're going to, that's our pre-image, and it's going to be reflected over this line of reflection here, and it's going to be reflected over to Z prime. And so you know that when you see the prime, there you think of the word image. Okay, so pre-image gets reflected over to the image. And here's the basic, simple little thing about reflection. So here is our image, because that's the one without the prime. So that's our, oh, I said image, didn't I? I meant pre-image. So here's our pre-image. And this is the line of reflection that they've given to us, that they want us to reflect this pre-image in. And so notice that we go where it's perpendicular. So if you're looking at yourself in a mirror, your reflection will always be, when you're looking at the mirror and able to see your eyes in the mirror, you will always be looking at that mirror at a 90-degree angle. Your line of sight will always be perpendicular to the line of the mirror. So we go a certain distance to that mirror, this line of reflection, and the image will always be the same distance beyond that. So if this distance was, say, 3 feet to the mirror, then we go 3 feet beyond that to get to our image. Okay, so that's just the simple basics. It will always be that way. And we always want to do one point at a time also. Now sometimes the point actually lies on the line of reflection. So like in this case, I said if it's 3 steps to the line of reflection, then you go 3 steps beyond the line of reflection. Well, what if there's no steps to the line of reflection? Then we take no steps from the line of reflection. So in other words, if you have a point that's on the line of reflection, when you reflect it, it does not move. It just stays right there. All right, let's take those basic principles and think about applying them to these particular situations here. Is that going to work? A little bit too big. Here we go. All right, so here we have triangle ABC. So that's the one here in the blue, triangle ABC. And they want us to reflect it across the line x equals 3. So we need to get familiar with, because in this case they showed us the line on the diagram, but we need to be able to draw and understand what that line x equals 3 looks like. All right, and then here's another line of reflection when y equals 1. Okay, so if we do not know what this line x equals 3 or y equals 1 looks like, then we don't have a clue how to reflect it. So let's practice and make sure that you understand how to draw a line of reflection. So like I mentioned, There are a few types of lines of reflection that they will give to us. Now sometimes they'll make it nice and easy, and they'll say either the x-axis or they'll say the y-axis. That's super nice and easy. But most times they're going to say y equals a constant, whether it's 1, 2, 3, or -5 or whatever, or x equals a constant, or y equals x, or y equals -x. All right, so we need to be familiar with these different lines of reflections so that we can plot this and then from there be able to reflect our pre-image. So what I'd like for you to do, and this is on my website, these notes here, so hopefully you can print these off. And then what I should have written in here is this is a horizontal line, so maybe up here. Please write that in there, horizontal. Horizontal line. Okay, so when you see y equals 1, I'd like for you to think of this as actually in the form of y equals 0x plus 1. And the reason for that is because I'd like for you to realize that this 1 is not the slope, but the 1 is actually your y-intercept. And so what is the slope? The slope is 0. So you can see here that if you do 0 times x, then this cancels out. It turns into 0, an invisible 0, and you end up with y equals 1. So that helps you to realize that my y-intercept is 1. So remember how to plot a line. You always start from the origin, and you begin at the b, begin at your y-intercept. And let's go up to the y-intercept. In this case, it's at, what is that, 0, 1 would be your y-intercept, where the b equals 1. And then from there, you do the slope. So the way you graph a line is first you begin at the b, you do the y-intercept, and then you do the slope. Well, we have a slope of 0. What does that mean? Well, it means we have a rise of 0 with whatever our run is. So let's say we had a run of 5. I'm just kind of creating a number. And so you go up 0 and then you run over 5. So you should be able to see and understand that when you have a slope of 0, that's going to be a horizontal line. Slope of 0 will always be a horizontal line. Okay, so get accustomed to that. Maybe you'll have y equals 3. All right, same principle here. Let me do the black. So here would be your coordinate grid. You would go up to 3. Let's do -3, right? Maybe a little bit harder, a little bit different at least. Let's go down now to, can I erase that, just that? Oh no, I messed it up. Let's go down to, okay, -3. Here we go. So -1, -2, -3, right? And then you do a slope of 0. So this is what the line y equals -3 would look like. Similar to, same concept as y equals 1. Got it? So y equals a constant will be a horizontal line. X equals a constant is going to be a vertical line. So if you want to write that in there, you of course will write yours neater than I am. So that's a vertical line. So let's think of, can we put this x equals 3 into the y equals mx plus b format? And the answer is no. There's no way to stuff that thing into that format. So we'll just keep it as x equals 3. So how do you plot the line x equals 3? Well, my recommendation to you is to think of it as, hey, the x coordinate is going to be 3. So we're accustomed to, okay, to get x equals 3, we go out on the x-axis over to 3. Okay, so I know this point is where x equals 3. Let's find another point now where x equals 3. So let's say 3, 1. So that's going to be up here. We still go out to an x of 3, and then we go up 1 on the y coordinate. We only need 2 points in order to determine a line. So there's our line. X equals 3 is a vertical line where the x coordinate will always be 3. You could also think about even this one as you go up on the y-axis 1, and then you stop there and freeze that y-coordinate, and then you can change your x-coordinate, make it negative or make it positive, but the y-coordinate will always be the same at 1. So that's going to be a horizontal line when the y-coordinate, or y, is equal to a constant, and a vertical line when x is equal to a constant. So get accustomed to that. Please, it'll be of great value to you. Here's the other two formats that we need to become familiar with. These are a little bit easier, I think. Y equals x. And I'd like for you to put that into, think of that as the format of y equals 1x plus 0. So that helps remind you that the y-intercept is 0. So you just start there at the origin. And then you have a slope of 1. There's an invisible 1 here in front of the x. And you understand a slope of 1 is the same thing as a rise of 1 over a run of 1. So you would, from this point, you would do a rise of 1 and a run of 1. So there is the line y equals x. So this is a diagonal line, and I'll show you here in just a minute that it will always go through those grid lines. So like on a graph you're familiar with on a graphing paper, and where those grid lines, those bullseye, the crosshairs of the grid line cross, that's where your diagonal line will always go through that. So a line y equals x is a diagonal up, diagonal rise, or how do you want to say that? Diagonal up is fine. Thinking of it as signing your name, going left to right, it's a diagonal up. Whereas the line y equals negative x is a diagonal down. So same concept that we just went through, diagonal down, or sloping down, however you want to say that. So your slope is negative 1. Now let me just make one small point here. Negative 1, you should think of that slope as a negative of 1 over 1. But if you're going to do the slope of that, it's going to be either a rise of negative 1 over a run of positive 1. So let's think of how we would do that. So here's a rise of negative 1. So this is going down 1, and then a run of positive 1. It's going over to the right 1. So these 2 points you'd start here in the origin, and then you do a rise over run to get this point. But you know that negative 1 over 1 could also be written as 1 over negative 1. All right? So if we do a rise of positive 1, that's going up here, and then a run of negative 1, that's going over to the left. And notice now that we have these 2 points. So whether you connect those 2 green points or those 2 pink points, it's going to be the same line. And why is that mathematically? Because a negative divided by a positive is negative, and a positive divided by a negative is also negative. All right, so make sure you understand that concept. It'll help you to understand these lines of reflection. Okay, so I think we're ready now. Now that we know, so when you see this x equals 3, you should be able to say, hey, I'm going to go out on the x coordinate, 3, and then I'm going to freeze my x coordinate, and then I'm going to go up and down. It's going to be a vertical line. So x equals 3 is a vertical line. That's vertical, spelled vertical wrong, but you get the concept. That is here at x equals 3. All right, now that we can draw, and this is our line of reflection here, this green line. So let's take one point at a time. Here is A, and because this is a vertical line, well, it's always going to be, see it this way, your line of sight will always be perpendicular. Remember that? It's always going to be perpendicular to your line of reflection. And in this case, that perpendicular, because our line of reflection is a vertical line, therefore our line of sight is going to be a horizontal line. So we can count these horizontal blocks, 1, 2 blocks, to get to the line of reflection, and therefore we count 2 blocks beyond the line of reflection, 1, 2. Okay, so A is, what is that, 1, 3? At 1, 3 is going to be transformed when reflecting over the line x equals 3. Is going to be transformed to A prime, which is at the coordinate of, and what is that? 1, 2, 3, 4, 5, comma 1, 2, 3. Okay, so there is the transformation for the A coordinate, and then you can do the B. Now notice the B is starting on the right side of the line of reflection. That's fine. We're just doing 1 point at a time. It's kind of weird when our figure is, like in the blue here, is straddling this line of reflection. When it reflects, it flips over. So this A flips over to the A prime, goes from left to right, but the B that's on the right side, it is 1, 2 steps toward the line of reflection, and therefore we go 2 steps beyond the line of reflection. So it started on the right and flips over here to the left. And then the C is kind of doing the opposite of that. It's starting on the left-hand side, and it's 1 block to the line of reflection, and it goes 1 block beyond the line of reflection. Got it? So here is y equals 1. So you should understand that as a horizontal line. After you kind of think that through, you should be able to graph then this line of y equals 1. And so here's your pre-image of A, and you're going to be a perpendicular line to that line of reflection. The line of sight is perpendicular to the line of reflection, and it's 2 blocks to the line of reflection, therefore 2 blocks beyond the line of reflection. And here's the point that's on the line of reflection, and so it's 0 steps or blocks to the line of reflection, and therefore it goes 0 beyond that line of reflection. Okay, so I think you're ready now to do these. Question number 1 here on your own. And I've kind of helped you out a little bit here, quite a bit in fact. So they're saying reflect the following figures over their line of reflection. So here is the line of reflection that they want us to use. So x-axis, that was nice and easy. So please, on your notes, please make this line of reflection nice and distinct. Here, maybe even draw an arrow towards that. That's the x-axis. And then take 1 point at a time. So I've already done point A for you. And remember, your line of sight has to be perpendicular to the line of reflection. And notice that each block is worth 2 units. Each block is worth 2 units. So I go 2 units toward the line of reflection, and therefore I need to go 2 units beyond that line of reflection. So A comes down here to A prime. And then B starts up here, and notice I'm counting half blocks because each block is worth 2 units. So 1, 2, 3, 4, 5. It's 5 units down to the line of reflection. Therefore, I go 5 units beyond the line of reflection. So you do the rest of it. You do point C here, and then fill in and draw in the image of this pre-image. And then you can do the same thing here. This is the y-axis is our line of reflection. And so you notice that I've done these 2 points. I did point F. I also did point G. So you need to do point D and point F. And then over here, I gave you this line of reflection. Probably should have let you do it on your own, but helping you out. So this is y equals -3. So you should be able to plot that thing on your own. But now you want to reflect each of these points. So in this sense, you're ignoring really this x-axis and just focus in on this line of reflection and then reflect each of these points over that line of reflection. And remember what you're supposed to do when you have a point that's on the line of reflection. Okay, so go ahead and pause the video and finish up those 3 on your own. Okay, so just a reminder, if you just copied this down and turned that in, you're not going to get many points at all, man. Got to try something on your own. Here we go. So let's do number 2. And this is the line of reflection is y equals x. Y equals x. So let me, what I should have done is come over here, and when we did those horizontal and vertical lines, I could have used this. This is also a very helpful summary of transformations that I would highly recommend, and this is also up on my website. I'd highly recommend that you get accustomed to this and keep on looking back here. So this is just explaining, like we talked about, that if we did point C, for example, it'd be 1, 2, 3, 4. This is our line reflection here in the green. So if we did 4 units to the line of reflection, then we have to go 4 units beyond that line of reflection. And let me just mention this to you before we go too much farther. So this is a summary of the rules of transformation. The rules of reflection. This is a summary of the rules of reflection. In these 2 particular cases, when y equals 0, that is, this is the same thing as the x-axis. Okay, so this is the x-axis, and the equation for the x-axis is y equals 0. Okay, same line there. And when you are reflecting a point across the x-axis, so let's say that you start up here, and this is at 2, let's say 2, 1. Okay, so the coordinates for this point are at 2, 1. And if you were to reflect it in the x-axis, then it would come 1 point or 1 step down to the line of reflection, and you want to go 1 step beyond that line of reflection. So if this was A, it would come down here to A prime. And the coordinates for that now would be 2, -1. See what I'm doing? I'm coming down 2, so I'm going from +1 on the y coordinate down to -1. So notice what I've done in changing. Let's do, I guess you could do it this way, make this green. When I reflect over the x-axis, or you could also say that as that y equals 0, I am not changing. I'm not changing the x-coordinate, and all that I'm doing to the y-coordinate is changing the sign, going from positive to negative. So therefore, my rule of transformation is that x comma y goes to x comma the opposite of y. See how that works? So x comma y, in this case it was 2, 1 for A, goes to A prime, which is 2, -1. So all we did was change the sign of that y coordinate. So therefore, if I was to give you another coordinate, let's say I gave you B, was at -3, -4, and I said, okay, let's do that same transformation where you reflect this point, point B, over the x-axis. Then B would go to B prime, And all that I need to do is x, I'm going to keep that same x coordinate, that's -3. And now I want to change the sign of the y coordinate. So instead of -4, it's going to be +4. So b, which is -3, -4, is transformed into, through reflection over the x-axis, is transformed into b prime, which is -3, 4. So do you see how easy that is? Once you figure out the rule of transformation, then all you have to do is just put that the point through that rule of transformation, and it makes it a lot easier than having to graph everything. So you are going to have some problems where you have just the coordinates, and rather than having to do all this graphing, it's a whole lot easier if you are able to memorize. And we're going to work on these so that it'll be pretty easy. You'll see the patterns here. Memorize these rules of transformation. Okay, and then for the y-axis, so the line x equals 0, as you know, is a vertical line. That's the y-axis. And so let's say we have a point over here, and this is at, let's call it 1 comma. Oh, this is going to be negative, right? Yeah. So let's call this -2, 4, and let's say this is a, and I'm going to transform this, so it's going to say 2 steps to the y-axis, and I go 2 steps beyond that y-axis, so a prime is going to be at +2, 4. So notice that the only change that I made was to change the sign. I went from change the sign of the x-coordinate. I went from negative to positive. The y-coordinate stays the same, 4 and 4. All I do is change the sign of the x-coordinate. Okay, so we'll practice those in class, but those are so helpful. Now, let's look at these diagonals. And let's do that by going to the textbook here. And let's go down to this y equals x. Same concept for these, except, so here's your line of reflection, y equals x, right? And so that the concept now, though, is, well, the same idea. So here's your pre-image of G, but and so this is the same, that your line of sight from your pre-image to your image is always going to be perpendicular. So your line of sight is always going to be perpendicular to your line of reflection. Maybe it'd be easier if I did it over here. I showed you also over here. So your line of sight from your pre-image to your image will always be perpendicular to your line of reflection. Right? We got that. Remember before, then we counted blocks on this line of sight. Same thing here. Before, when we did it, when we reflect over the y-axis, then we counted horizontal blocks. When we reflected over the x-axis, then we counted vertical blocks. So the only thing different now, when we have a diagonal line of reflection, we count diagonal blocks. So a little bit strange there, but we need to count diagonal blocks. So here, think of this as 1.5 diagonal blocks to the line of reflection, and therefore we go 1.5 diagonal blocks beyond the line of reflection. Make sense? Over here, we're going half of a diagonal block to the line of reflection, and therefore we go half of a diagonal block beyond the line of reflection. Okay, so remember I said with y equals x that it'll, think of this as y equals, let's do it this way, y equals 1x plus 0, right? So that when you plot it, you're going to start at the origin, and think of this as a slope of 1 over 1. So you do a rise of 1 and a run of 1. So notice that your line of reflection will always go through, remember how I said crosshairs or bullseye? It will always go through the intersection of these coordinate grid lines. Always do that. And the same thing for your line of sight. So notice that as I'm drawing this line of sight, it's also going from diagonally across these coordinate squares. And it'll always go through these intersections of these coordinate grids. Okay, so that'll help you. But it's kind of a skill there to realize where that line of sight is. Now the last one we have is y equals negative x. Same concept. Same exact concept. Here's the line y equals negative x. Again, think of this as y equals negative 1, x plus 0. So in order to plot this line, which you will have to do sometimes, plot the line y equals negative x. You start at the origin. And remember, a slope of negative 1 can be thought of as negative 1 over positive 1. So if I did that slope, it'd be a rise of negative 1 and then a run of negative 1. Or it can also be thought of as, let's make this a bit bigger, thought of as a slope of 1 over negative 1. In other words, you have a rise of positive 1 and a run of negative 1. So notice that whether I connect these blue dots together or connect those black dots together, I have the same line. I have the same line. Okay. And so now that I have my line of reflection plotted, now I need to draw my line of sight. So I'm coming from point G. Here's my pre-image. And remember, I always go through these intersection of the coordinate grids. So I always go through those. And I have 1.5 diagonal blocks to get to that line of reflection. Therefore, I go 1.5 beyond that line of reflection. And same thing over here. I have half of a diagonal block to get to the line of reflection. Therefore, I go half a diagonal block beyond that line of reflection. So let's look at this one now and try to pull the rule. This is the last thing I have to do before I cut you loose to be able to do your work. But this is important. So this point here, G, is at 1. So 1 comma 2, right? So G is at 1 comma 2. And then G prime is at negative 2 comma negative 1. All right, so let's kind of write that out. So here I have G is at 1 comma, what did I say? 1 comma 2. Here it is. And that gets transformed over to G prime, which is negative 2 comma negative 1. Okay, so here's the question. What is my rule of transformation? Okay, so when I have a diagonal like this at y equals negative x, I can create a rule of transformation. So I can do that for x equals 0 or for y equals 0. By the way, before I forget, you cannot do that for like x equals 3 or y equals negative 2. These lines you cannot create a rule of transformation for. But the y axis you can, the x axis you can, and y equals x you can, and also y equals negative x. All right. So what is our rule of transformation? So how do we get this G prime? Well, this negative 2 came from where? It came from your y coordinate. Okay, so I know this is going to be, let's make it up, give me some room here. I know this is going to be y, but what did I do to the y? Well, I did the opposite of it. So I want the opposite of y. Don't think negative because it could be a positive number, but it's the opposite of y. So whatever y was, I want the opposite of that. Okay, that makes sense? And now, where did I get this negative 1 from? Well, I took what used to be the x coordinate and I did the opposite of that x coordinate. So x comma y, here's my rule of transformation. X, let me kind of write a straight line here. X comma y turns into, is transformed into the opposite of y, comma, the opposite of x. Okay, so let's test our little deal here. Here is f, and so what are the coordinates of f? It's at -1, 2, right? -1, 2, and that transforms to f prime. Well, let's go ahead and do it this way. That transforms to f prime, and what are the coordinates of f prime? It's -2, 1. So -2, 1. So does that work? Let's see. Let's take x, y, all right, and we want to have it transformed into the opposite of y. So is that what we have here? With this -2, do we have the opposite of y? And the answer is yes. Y used to be 2, and the opposite of 2 is -2. Hey, that works. And then here, with this 1, is it the opposite of what x used to be? X used to be -1, and the opposite of -1 is +1. But bingo, it works. Okay, so you see how easy that is? So if you can create a rule of transformation, or even better, and we will be doing this in class, is memorizing this and the other 3 rules of transformation. So those are over here. So here are the rules of transformation. That's sloppy. The rules of transformation that we want to memorize. And this is the one that we just did. Here, the opposite of y and the opposite of x. That's the one we just figured out, but that's the one that each one of these here are what you are going to be memorizing, and it makes life so much easier to be able to do these transformations, or these reflections. Okay, so you are ready now to do number 2 on your own. I've given you some little hints here. In the gray, those are your line of sight that are perpendicular to this line of reflection of y equals x, and we're counting diagonal blocks. And same thing here. Here's your line of sight, and here's your diagonal blocks. So I've started you off with point C. Here's your line of reflection. You count the number of diagonal blocks to the line of reflection, and then go the same diagonal blocks beyond it. Right? And then draw in your shape. I've given you less help over here, but you can do that on your own. I've also given you some help down here. So that's it. Hope you do well, and I look forward to seeing you guys in class.